Hello everyone, welcome back to another video. Today I'll be introducing trigonometry. So first we'll go over the Pythagorean theorem and how it introduces it. Then we'll talk about some basic trig functions. Then we'll go over angles and the difference between degrees and radians. And finally we'll talk about some basic trig identities. So first, Pythagorean theorem, a squared plus b squared equals c squared. And it's about a triangle with two side lengths. And this would need to be 90 degrees, or these sides are perpendicular, and that means the hypotenuse is c. So this means the hypotenuse is always at least as big as a or b, and generally we'll follow this formula. But what we can do is we can do some simple algebra and rearrange this equation, divide by c squared, and we'll get this. So this is the ratio of a to c and b to c, which is the ratio of the side length to the hypotenuse, and relating it to 1. And we could change this, where this term would be x and this term would be y. And this, if we plot this, we would get a circle with radius of 1. And this is what we call the unit circle, where all of the points, x, y, on the circle is 1 away from the origin at 0, 0. And for every single point, it also kind of represents a triangle, where the hypotenuse is 1, and then a and b are instead x and y. And every point on the circle, x and y will be between -1 and 1. Now let's start going over trigonometry. This shows us how far we can move this point along this circumference, and we describe that with an angle, theta, and have functions that use this theta as input and tell us some things about x and y. So for these, it's useful to have, based on this angle, we'll call this side adjacent, because it's adjacent to it, this side opposite, because it's opposite to it, and this is the hypotenuse. And so sine of theta is essentially just the y value on a unit circle, given this theta, or this angle. And it will always be the opposite over the hypotenuse. When the hypotenuse is 1, it's just the opposite. Cosine, which is the x value, is the adjacent side over the hypotenuse. When the hypotenuse is 1, it's just the length of the adjacent side. And tan of the angle is the slope. So it's going to be y divided by x, or the opposite side divided by the adjacent side. And all of these essentially map an angle which could extend for any different hypotenuse length, but it all maps it down to the unit circle where the hypotenuse is always 1, which makes its behavior a lot more predictable. And with these, if you can remember SOHCAHTOA, which is the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. This mnemonic can really help you remember that for anything you might need it for. There are also these functions where cosecant is the reciprocal of sine. So 1 divided by sine is cosecant, 1 divided by cosine is secant, 1 divided by tangent is cotangent. And these names are based on the original names. So sine and cosine, because cosine is a cofunction of sine, that means this angle, if this is the sine, then this angle, if you take the cosine of it, you'll get the same exact values, which makes sense, because if this is adjacent and opposite for this angle, if you do this angle, it will swap them. And so secant and cosecant are cofunctions, tangent and cotangent are cofunctions, the same way that sine and cosine are. Now let's go more into angles. So an angle describes kind of how far from the x-axis, the positive x-axis, you've traveled. So going around the unit circle counterclockwise. So in degrees, if we call one full rotation, we would call that 360 degrees, right? Which would make this 180, this would be 90 degrees, this would be 270 degrees, and every intermittent point as well would have a degree. But we can also describe it in radians, where a full rotation would be 2 pi. And the reason it's 2 pi is because the circumference of a circle of radius 1 is 2 pi, or about 6.28. So you're kind of just describing how far along the unit circle you've traveled the circumference of. And if you have a bigger circle, you're always relating it down to the unit circle, because that is the most uniform and easiest to talk about. But another reason angles are used is for arc trig functions or inverse trig functions. So let's say we wanted the angle of this, then we could use arcsine to find it. So let's say we had x and y, and we wanted to find theta. That's where we'd use these inverse functions. If we had theta, if we had the angle, and we wanted to find x and y, we would use the normal functions, sine, cosine, tangent. But if we have the x and y and we want to find theta, then we would use the inverse. Usually the inverse to get back to where you were. And this is an example of r used as the radius. So we can call this c, we can call this h, we can call this r. On the unit circle, it's always equal to 1, but on a general triangle or general circle, it can be equal to anything. Now finally, we'll talk about some of the common trig identities you'll be using. So generally, we have the basic trig identities. This is the most common one. Sine squared plus cosine squared equals 1. That's basically the a squared plus b squared equals c squared, or the x squared plus y squared equals 1. That's literally what this is. But then we can use basic algebra. So here we're dividing everything by sine squared, and then we get this formula. And so we haven't actually done anything, but this is still an identity that we can use if we want to do some algebra magic. And then if we instead divide by cosine squared, we'll get this formula. So these are useful. You can also use them in further studies like calculus. But generally this is the most fundamental identity of trigonometry. Then there's double angle identities, where sine of 2 theta is equal to 2 sine of theta cosine of theta. This is useful if you want to relate different angles to each other. And there's also one for cosine and tangent, and they're called the double angle identities. And then there are also the sum and difference identities. Like the double angle, it's relating two different angles to each other. So let's say we had 15 degrees and another 15 degrees. Then we could find out what 30 degrees was. So there's one for sine, where this plus would transfer over. So sine of alpha plus beta is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. But if this was minus, this would also be a minus. But for cosine, the signs are actually switched. So if this is a plus, then this would need to be a minus. If this was minus, this would need to be a plus. And tangent also has one, where one of these is the same, and then the one in the denominator is actually the opposite. These aren't the only identities. There are a lot more, but these are the most fundamental and basic ones. And you could probably pretty easily derive the rest of them with these ones. This is just an introduction to trigonometry, and there's a lot more, and if you want to get good, there's nothing else you can do but just practice some problems. So let me know if you want me to go through some example problems, and comment any other questions you have, and I will see you in the next video. Thank you for watching.